Hey everyone, and welcome back to my C# tutorial. Today we're going to go over some data types, all of your basics. We're going to talk a little bit about the var keyword, have an input example, look at the convert class. And last time we went over C#'s paradigm, which is object-oriented programming, talked about the code in here, some basic I/O and the functions, how they work, and then the console class. So getting right into it, we have our Boolean data type. So bool, some bool equals true, for instance. So a bool can hold a true or false value. A more useful name might be something like game active. So say when your game hits some condition, you can say game active equals false. And that would make sense. So that's our bool. The most common data type that you're going to use to store your numbers into arithmetic will be integers, which you use the int keyword for. If you want to be fancy and specify exactly how many bits you're using, you can do something like int32 or int64. Almost nobody does that though, so don't. So we'll have our integer equals to 0. Okay. And an integer is 32 bits by default, as declared by C#. So that means we have 2 to the 32 in values. But that's not really the case because by default, everything in C# is signed. So what does that mean? Basically, in order to hold to negative values, so I'm gonna do this here. In order to hold to negative values, the computer has to reserve a single bit. So this was 8 bits, now it's only 7 bits, but with this first bit reserved, if that's set to 1, the computer now knows, okay, so this is a negative value. So in essence, it chops down its max value by half, but that means that it can hold negative values as well, divided by 2. And also -1, because that's just how it is. So in theory, we should be able to set this equal to that, to 147, 483, 647. And that is the case. Let's see if we can add 1. Looks like we actually can. Huh. That's kind of odd. Oh no, never mind. So that was wrong. Looks like we can have up to that many. I'm guessing that when it's positive, we can't have that many though. Okay, yeah, so when it's positive, it's -1. Little weird things with C# like that. Okay, so you get the basics of that. Let's say that you only need positive values and you want 0 to the max 32-bit value. What you can do is instead of an integer, you can use an unsigned integer. So you just prefix with a u, and now it is unsigned. So you can set it equal to that max value that we talked about. So 4294, 967, and 296. -1. Okay. Now there's also the short data type and the long data type. They work exactly like an integer, although you want to be careful if you're converting from a long integer or a long data type to an integer, because this can hold up to 64 bits. If there's more data there than an integer can handle, then it's just going to chop that off or not use it, so it won't be accurate. So be careful of that. So let's say we have our lon data type equal to some ridiculous value, some value that's larger than what an integer can handle. You can technically do something like this, and you can say uint lon data. Let's see. 1 second. Oh, wait. I'm doing that wrong. This is how you're casting. Okay, there we go. So if you cast an unsigned integer to a lon, then it will allow you to use this, but an unsigned integer can't hold this much data, so let's just see what happens. We're going to print that out to the console, so unsigned int and console.readline. All right. All right, yeah, so obviously this isn't that value, and what's happening is it's overflowing, so when an integer can't hold this much data, or any data type that you're using, it's essentially going to reset itself to 0 and then keep adding the numbers. So what do I mean by that? So say this was the maximum that an integer could hold, and we add another 4, it's going to keep resetting it to 0 and adding until it's able to add all of these in. Yeah, that's how we cast a larger number to a smaller number. But as we saw, it doesn't really work out if you're holding more data than the maximum that an integer can hold. However, if we make this smaller, obviously this integer can hold up to that number, so we're going to see here how that goes. Actually, just to make it easier, I'm going to do 1, 2, 3, 4, 5, 6. All right, yeah, so you can do that, and sometimes you might have to do that. Depending on how large the numbers can get, though, you may not want to. So our next special data types are the float and double. And what are those? Now, CPUs used to process floats a lot faster than doubles, but CPU architectures have improved by so much that these days it doesn't really matter. So we're just going to use a double here. And this is the one you'll most common see. Nobody really uses floats. So we'll do this double number. All right, so what is so special about doubles? Now, if you're going to use just whole numbers, then don't bother using a double. But if you're going to be storing, say, decimals, so like 3 point, all of this, or if you want pi 141,592, and it's able to store that data. So we're going to print that out to the console. And there we go. And you kind of just have to trust me that this is a number. Well, actually, let's do something with it to prove that. So we're going to take our double number. We're going to add 1 to it. I'm using the plus equals shortcut. You could also use plus plus. That's the same as +1 or minus minus to subtract 1, which is equivalent to this statement here. But obviously it's a lot more concise to just go plus equals 1. Now we're going to console.writeLine this same statement and check it out. So we added 1, and that was using just regular arithmetic operations. We could also do this. And there we go. Okay, so our next data types are going to be the char and string types. So what are these? Well, basically, your char type or character can hold a single character. Now you always reference these by using single quotes, and like it says, it's going to hold a single character. I don't very often use these, but you might, I don't know. Another data type that you might be using would be the string type. So this can store a full string, which could be something like this. And just because we can, we're going to console.writeLine that to the console. And I'm also going to comment these out. All right, and there's our string. Now, I don't know if you remembered me mentioning this, but this is part of our basic input and output. So we're going to use console.readLine to enter in data. And let's see what that looks like. All right, so we're going to input this into that read line, and then it's going to set the string equal to that, and we're going to print that again to the console. And that is exactly what we've done. So that's kind of cool. And some special mentions. There's the decimal type, which can hold up to 20 decimal places, I believe. You might use this when you're doing like banking calculations or something along those lines. Most of the time, you definitely won't need this, though. So for special applications, it's useful, but for what most people are doing, it's more slow than it's worth. And then there's the byte data type. Now, a byte by default is actually unsigned. So it's the full 8 bits, and you might use this when you're reading, say, files into C#. That's the case where I've used it anyway, where you create byte arrays and fill them with data. Now we have the var keyword. So C# is somewhat dynamically typed. It's not strictly dynamic, but in a language like Python, you don't really have any of this. The Python interpreter just kind of figures it out for you. But in C#, you can use the variable keyword to figure out things for you as well. So we're going to set var data equal to just something. And it looks like it's automatically assigning it to a double. So that's a pretty good guess. However, be aware. So don't use this in trivial cases. You don't know if the compiler might choose some other data type that you weren't intending on using. And it also looks a lot more abstract than just declaring it as a double. Yeah. However, if you're doing something kind of complicated like this with a dictionary, now this is a case where it's actually acceptable to use var, because otherwise you have to do this. And who explicitly wants to define this? And imagine if this is in another class in another file. Then you definitely have no need to explicitly define this. You can just use the var keyword and let C# figure it out for you. And that's an acceptable use case, like I said. Now I promised that we would use, or we would go over an input example and use the convert class. Our input example could be that string, but now let's go over the convert class. So I'm going to have some integer, and I'm going to use convert. So to int 32, and then some string. And then instead of printing some string, we're going to print some integer. Okay, so let's say 100. And there we go. And just to prove that that's actually an integer like we said, I'm going to use ++ this time. Right. Forgot to enter our data first, right? There we go. Don't know if you saw that, though. Okay. So that is all for today. Thank you for following along with this C# tutorial series. And this is Valkyrie signing out.